Swayam Prabha. Digital India. Educated India.
Hello all, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 4 and lecture number 36 on orthographic projections, and we are working out few examples on line projections. Let us begin. The third example is, there is a top view. In that 75 mm long line CD which measures 50 mm, and its end C is in horizontal plane and 50 mm in front of vertical plane. End D is 55 mm in front of a VP and it is above HP plane. If that is the case, draw projections of CD and find angles with horizontal plane and vertical plane. Let us look at the solution. So, here the xy plane, first one has to construct. We can see end C is in horizontal plane. So, when it is in horizontal plane, the projections, if we are seeing that, it will be on xy axis. So, one of these projections has to pass through that point. And now, we have to locate C prime which is on xy, which is horizontal plane, and C 50 mm below that xy plane. Because its NC is in horizontal plane and 50 mm in front of vertical plane. So, when we have such kind of line in 3D pictorial view, if this is the horizontal plane, in front of vertical plane at 50 mm, our line point begins in capital C, that is something like 50 mm, and it is in this plane. So, locate that C point, then draw locus from these points. So, we have 2 points C and C prime, this is the locus line. Then draw another locus line 15 mm, because this end D is 15 mm in front of vertical plane. So, from vertical plane we do not know whether it is here, here and so on. So, somewhere here this point is at 15 mm. So, this is the one, because C is at 50 mm is supposed to be there and D is bit closer. So, it is at that point. So, for that, to identify that, we are locating this entire thing as a locus. Once that is done, we have to make 50 mm and 75 mm distances on locus D from C. So, this is the C point, locate 50 mm cut and also 75 mm cut, because end C is in HP and 50 mm in front of vertical plane. I am sorry. So, we will be in a position to make a cut here to locate D and to locate D1 prime, D1. Then from D1 draw a vertical line all the way up to project it, which is 0.6, and from there draw an arc by measuring C prime to this projected line LFV draw an arc. It can be extended all the way there. We have already located D point. So, draw a projector line which cuts that to indicate D prime. Once we know D prime, join C prime and D prime, and that will be the front view. Once we know D prime, draw a projector locus. Already C to D1 is our true length. So, measure that CD 1 and from C prime make a cut onto that locus called D prime 1. This is the way we construct our diagram. So, this again becomes true length and this angle is the true angle. Similarly, the line C D1 prime with horizontal axis, whatever angle it is making, true angle phi we will find. So, here unknowns are projections of CD, that is our front view and top view, and angles with horizontal plane and vertical plane. These are the things which are unknown. So, let us do it on the sheet once again. So, on the drawing sheet, first we have to draw a horizontal line xy. Name this x axis, y axis, and draw a vertical line to locate this projector. This is the projector, and our C prime is already on x axis, xy axis. So, C prime, and C is 50 mm below that line or in front of vertical plane. Locate 50 mm here. This is C. Draw locus from these planes. In that way. Similarly, draw 15 mm locus line below xy axis. This is the line, axis we will be in a position to locate, and D or D prime will be at these levels. Once done, make 50 mm cut. So, let us measure 50 mm. To locate D lines. So, this is 50 mm. So, we have to make a cut from C, make an angle there to locate D. Then 75 mm we have to locate. mm. So, this point let us call D1. Join these points. CD is our top view line, and true length line from C, if we are joining D1, this gives us our true length. Now, draw the projectors to locate top view and true length on that vertical plane. So, this is one projector, other one is this projector. This supposed to be a projector passing through okay. This is the line. Now, what we have to do is this angle we will measure, let us call phi, and this is true length, and this one is top view. Now, we have projected D1 onto axis xy. From there we have to rotate it to construct these views. So, let us measure this line. So, let us draw an arc which is passing through that. Already we know true length. So, locate true length on this axis. This is the one which comes somewhere there. After drawing our locus, we will be in a position to find it. Now, the locus for D is this D prime, the projector lines, and from C join this line to locate our front view. Once front view is there, the locus line passes via D prime, and this point, because this length what we have transferred from here to there, we transfer it on that axis. It cuts there, let us call D1 prime. Again our true length in that vertical plane, projected one, this is the one, and this angle is theta. Let us measure this angle. The phi angle with horizontal, it makes 29 degrees, and the theta angle is 46, and true length is 722 mm, and this is also true length. Now, let us solve one more problem for our projection of lines. So, let us look at this slide. Here, example 4, there are two straight lines PQ and QR. So, it is not just one line, but two lines PQ and QR. They make an angle of 120 degrees between them, in front and top, in the front views and top views. PQ is 60 millimeter long and is parallel to and 15 mm from both horizontal plane and vertical plane. If that is the case, determine the true angle between PQ and QR if point R is 50 mm above horizontal plane. So, there are two lines P and Q, these are true ones, and Q are also there. That means, the other line supposed to pass through Q, maybe that is R. They make 120 degrees angle between them, and these are in front in the top views. PQ length is 60 mm we know, and it is parallel to and 15 mm in front of HP and VP. Is both from horizontal plane and vertical plane is at this 15 mm. If that is the case, can we determine the true angle between this PQ? So, let us solve that problem step by step. First, draw a reference line xy on the plane. Then mark a point P prime 15 mm above HP. So, this is 15 mm above that HP. In the front view, we are projecting that 15 mm, so that P prime point will be at 15 mm. Similarly, P point, when we are looking from top view, that is in front, so 15 mm below. Then draw 60 mm long lines P dash, Q dash and PQ parallel to xy axis. So, it is a line. What we are seeing is projections in the front view and projection from the top in the top view. So, from P point draw a projected line P prime Q prime, which is 60 mm, PQ is 60 mm long. So, 60 mm and it is parallel to this xy axis, and 15 mm is from both horizontal plane and vertical plane also. So, once we are done with P prime, Q prime and PQ, which is also 60, the projected ones, we have to draw a line from point Q prime. So, we have located Q prime point and a 120 degrees line we will draw it in that way, and this meets horizontal line at 50 mm above xy. So, at 50 mm draw a horizontal line, and let us call this point as R prime. Once R prime is located on that horizontal, we can connect Q prime and R prime. Q prime is this, R prime is that, join that line. And P prime R prime also we can construct P prime R prime. This is the way we construct it. After that, the fourth one, draw a line from point Q. From Q, draw a line which is at 120 degrees inclination angle, in that way, 120 degrees for that, and it meets the projector R prime. This is the projector line at this location and call R. Then join QR and join PR. This is R, and then join this point P and R. First of all, let us construct these steps on our sheet. First, what we have to do, draw a xy line. X axis, y axis. Then mark points. So, draw a projector line. which is 15 mm above xy. Locate that point P prime, lowercase letter. Similarly, 15 mm below this one also. So, let us call this point P. Draw horizontal lines, locus lines, both from P and P prime. These are the projected lines. Now, 60 mm long lines, locate it. So, here and let us call this point as Q prime. Similarly, this point is our Q. Join these lines. Now, from point Q prime 120 degrees to xy such that it meets a horizontal line at 50 mm above xy line. So, first of all, let us locate 50 mm line on the sheet. Somewhere there. So, locate that line. From Q prime, let us locate this 120 degrees. And let us call this point as R prime. Once R prime is there, we can project that all the way down to construct R. Already we know Q. From there 120 degrees angle we already knew. Here construct to locate R, then join P and R. P, Q, R lines are projected in that way. Let us join this P and R prime also, P prime and R prime. Now, we have to locate R 1 prime, R 2 prime. Let us call this is at 50 mm above. On this, we are going to locate R 1 prime and other lines. Now, we have to draw these PQ line, PQ prime are parallel to xy and they are representing true length side of PQs, which are 60 mm things. Now, we have to draw an arc with center P. Let us look at our example 4 on the slide for the steps. Once this construction is done, look at this step 5. As lines PQ and P prime Q prime are parallel to xy, they represent true length side of PQ. Here PQ is 60 mm. Now, we have to draw an arc with the center P from here and radius PR, that is this P to R, so that we can locate a point R1. So, in this direction we locate R1. After that, project R1 all the way up to locate R1 prime, and then join P prime R1 prime. In that way, and this represents true length of the line P and R. So, P, Q, R are the things, and whatever the P to R, that true length, we will get it in this way. So, P prime R1 prime, we will get it as 94 mm. Let us calculate that. So, on our drawing sheet, once we have located this P R, locate draw an arc, have a projector for this point, this is R1, project that, let us call this one R1 prime, and join P R prime. P prime R 1 prime. So, after drawing this P prime R prime, P prime R prime and also P prime R 1 prime, connecting these points. Now, we will move on to 7th point, where we have to draw an arc with center Q and radius Q R, that is from Q R radius to meet horizontal line at R 2. So, with this radius, if we are going in this way, we will locate R 2. Then project this R 2 all the way to locate R 2 prime. So, let us do that on our drawing sheet. We have located P and also R. From R and Q R radius, from Q R radius, project it onto this horizontal axis, to locate R 2 line. Once R 2 line is there, join Q prime and R 2 prime. So, for that we have to project this entire line. Here we have located R 2 prime, then join Q prime and R prime, R 2 prime, Q prime here, R 2 prime here. So, from P and this is R, we take a arc, project it to R 2 line, from there project it R 2 prime, we got it. And then join this Q prime R 2 prime to represent true length of a line Q R. So, this is true length of our Q point, Q to R. Once it is done, we will draw an actual triangle. So, we have to transfer this one to locate from P point R 1 prime similarly locate from Q 1 prime R 2 prime. If we are seeing, this is the point what is intersecting. So, now join these lines from P prime, join this one, rename this one as PQ line, and from here Q to R. I am sorry, this is not, this is R. So, we have a QR line which goes through that, we have a PR line and we have a PQ line. Now, if we are seeing this angle, the angle made by Q and R will be around 113 degrees, and this length what is required and this QR length what is required. This is the way we construct this true angle between PQ and QR, the PQ angle. So, angle between PQ and QR which is around 113 degrees. Here 112 degrees, 113 degrees is because of your drawing lines, how careful we are in terms of drawing it, how we are projecting it. Based on this 1-2 degrees angle always be fluctuating. And we will learn a new concept in this slide. It is what you call trace of a line. So, the point of intersections of a line or their extension with respect to the reference planes are called traces of a line. And there are different kind of traces of a line with horizontal plane and also vertical plane. Let us look at with horizontal plane. A line itself or its intersection, if it touches horizontal plane, we call trace of a line on horizontal plane, and usually we denote it by HT symbol. And this is a point on horizontal plane, and it is called TV of a point in HP also, top view of a point in horizontal plane, because it is intersecting. When you are looking for example, let us take a pen and that is going to touch this point. So, this is the line which is going to touch that. So, it is going to intersect this reference plane, and that point what we are calling trace. And if it is going to intersect the horizontal plane, we call that one as HT point. And when it comes to front view, straight away the projection comes to XY line because it is touching the point. So, when you are projecting it, it goes on to that projection of that XY line, and that point we usually denote it by H, a small h. Similarly, if a line is touching the vertical plane, the intersection point, either that or the extension point, that is what we call trace of a line on vertical plane, and usually we denote it by VT. And this is a point on vertical plane, and when we are looking from top view, this point is intersecting with the XY axis. So, we will see it on XY axis. More about traces and these lines we will learn in the later classes, along with our planes if they are going to intersect intersecting with these horizontal planes, vertical planes, how these planes we have to really transfer it for different projections. See you in the next class.